It's August 21st, 2017, and this is the K-12 Engineering Education Podcast. In this episode, we celebrate two really important words in engineering: verification and validation. Engineers across every discipline should know about these fundamental concepts. Know the difference? Listen up. Next. I'm Pios Wong. Recently, on another podcast of mine called Engineering Word of the Day, the very knowledgeable engineer and consultant Pat Sweet joined me to talk about two of his favorite words in engineering. It was a great set of conversations, so before those episodes get archived away from that podcast and disappear off the internet, I wanted to share them on this show, because the conversations probably concern engineering educators just as much as working engineers. So, let's get into part one. Welcome, Pat. How are you doing?
I'm just fantastic. How are you, Pius?
I'm all right. I'm sitting here in Texas trying to get some podcast episodes ready, and you are in Canada, right?
Yeah. Halifax, Nova Scotia, so the far east coast of Canada.
Awesome. And you are actually the first guest that I'm having on my Engineering Word of the Day podcast, so this is a little bit of an experiment. Thank you for doing that, for joining me.
Thank you for having me. This will be exciting. It'll be a lot of fun.
Yeah, and I know just a little bit about you, but maybe people listening don't know who you are. Could you explain your background?
Yeah, absolutely. So again, my name's Pat Sweet. I'm a professional engineer. Been practicing engineering in Canada for over a decade now. And I run a blog and a podcast called Engineering and Leadership. So you can find that at engineeringandleadership.com, or the podcast is on iTunes if you just search Engineering and Leadership. And what I'm interested in and what I do is I help engineers and engineering companies thrive through a better understanding of the business and professional side of our profession. So I kind of recognize the fact that a lot of my own success in my career came as a result of understanding the soft skills and the business side. So eventually I went out and got an MBA and moved into product management, which is a really cool field that kind of merges both business and engineering. And I absolutely love that. So it's that kind of nexus where I operate now. So I do consulting as my main occupation now, and I do speaking and training and that kind of thing. So anyway, given that, I love being on podcasts. I think it's a phenomenal way to meet people and to reach out to new people. So I'm super excited that you've invited me here today.
No, that's excellent. So we heard that you are a PE, a professional engineer. You also are a businessman. You got an MBA. It sounds like you're very well qualified to know all about engineering jargon and terminology. Before we get into your favorite engineering words, because you do know a lot about, I guess, climbing up in the professional careers of engineers, why are communication skills and language and these soft skills, why are they even important for engineers to grasp?
It's interesting to say that. I, just before we hit the record button, I was telling you about a seminar I gave in Mississippi a few weeks ago. Mm-hmm. And I dedicated about a quarter of my time to communication skills. In my own professional experience, what I've noticed is that there are plenty of engineers who have brilliant ideas. I like to think that engineers are a pretty bright bunch. The trouble is, if you can't effectively communicate those ideas to anyone else and really convince them of the value of those ideas, you might as well have not had the idea in the first place. So if you can't use communication as a tool to get done what you're trying to get done, be that a new design, a new idea, an organizational transformation, a change to your project. It really doesn't matter what it is. If you can't get across to others the value of your ideas, then you're dead in the water. So understanding the right way to communicate, the right people to communicate to, is absolutely critical.
All right. So I guess people can go look up engineering and leadership and consult with you to try to find out how to better communicate as an engineer, right?
I like to think so, yeah.
All right. Well, I also wanted to ask you about some of your favorite engineering terms. I was wondering if we could talk about one of them in particular, validation. Validation. Is that correct? Is that one of your most interesting engineering words?
Yeah, it sounds like a boring word, but it's a super important word. So validation with respect to a design means that you're actually designing the right thing. A valid design actually fits the need that your client has. And a client doesn't have to be someone external to your company. It could be someone else you're doing work for internally. Mm-hmm. The reason validation is important is that your client doesn't always know what they want. They have a sense for the fact that they have a need. There's a problem, a pain, or a fear that they have that they want addressed. And often clients will come to you with an idea of what they want, but might be thinking too narrowly in terms of what the actual solution is. So let me give you an example. I used to work in the rail industry. Yeah. And often what would happen is we would have clients who would come to us and say, I want this kind of train. I want it to weigh this much. I want it to go this fast. I want it to be this color. When in reality, what they wanted was some kind of a system that would move 20,000 people per direction per hour. Mm-hmm. So the real need was to move the people. What they were asking for was a specific kind of train. When in reality, there are any number of different kinds of systems or designs that really could be valid.
Right.
As opposed to just that one that was specified.
That sounds like the engineer's job, especially in that beginning phase, is to really understand not only what the client or the customer is saying, but maybe what they're not saying, and just understanding their overall problem. For sure. And it's not even just understanding the client's problem, it's helping the client understand their own problem. Okay. And if you're not able to do that, then it's very difficult to get to a valid design. And no matter how many brilliant ideas you have, no matter how much time or effort you put into a design, if it's not valid, the project will fail. The design will fail. Yeah. As technologically advanced and fancy as it may be. So validation of a design is an absolutely critical first step, no matter what it is you're designing. All right. And real briefly, how can engineers validate a design? How can they help, or how can they figure out if a design or design idea will actually solve a customer's problem? One of the most basic ways, and probably the most important way, is to keep the client in the loop. Don't wait till you've completed a design. Don't wait till it's, ready to be manufactured before you let the client in on what you've done. There are quite a few books out there about lean design and Scrum project management that are, to me, really, really fascinating. But what it all boils down to is show the client early and often what you're working on, so that when you do need to make adjustments, because you will, you can't read the client's mind. If you have something to show them and they can give you feedback early, you can adjust course along the way so that you're not starting from square one after putting all sorts of time and effort into it. So incremental validation is the way to go. So Pat, that's really interesting. I guess I learned that validation is kind of an ongoing process within the design cycle. And I hope that everyone listening, especially the engineers listening, really take that to heart. Yep, absolutely. I think you've got it. All right. Thank you. I've just spoken to Pat Sweet, engineer and consultant. You can find him at engineeringandleadership.com. Thank you so much. Thank you very much, Pius. And now here's part 2, the conversation we had, which is an important follow-up to the engineering terminology of validation. All right, welcome. I'm talking with engineer Pat Sweet, professional engineer, in fact, PE. Welcome, Pat. Thank you very much, Pius. It's nice to be back. And this is part 2. You were previously on this Engineering Word of the Day podcast to talk about another word, validation, and we're going to talk about a very related word pretty soon. But just real briefly, just as a recap, can you explain to everyone listening who you are, what you do?
Yeah, absolutely. So my name's Pat Sweet. I run a blog and a podcast called Engineering and Leadership, which you can find at engineeringandleadership.com or on iTunes. And what my work is all about is helping engineers and engineering teams do better work, to help engineers and teams thrive through an understanding of the business side and the management side, the soft skills of engineering. The whole idea being that throughout my own career, I recognize that the people who really advanced and the teams who really did fantastic work were teams that were well-rounded in that regard. So that's what I'm all about. So I do speaking, I do consulting, and that's the nature of the work.
And you have plenty of experience. You're up in Canada, but you travel all around, it sounds like, to help engineers and businesses do better work. And you're drawing on, I guess, your background in both business school and also your engineering background as a PE. I just wanted to ask you briefly before we get into our engineering jargon here. I'm going to ask you about another piece of engineering jargon, the PE, the Professional Engineering Designation. Can you explain what that is in case someone doesn't know?
Yeah, no, fair enough. In Canada, we to differentiate ourselves, we decided to call it P.Eng, but
I did not know that.
Yeah. But fundamentally, it's the same thing. Where I studied and where I practice in Canada, your professional engineering designation is an absolute requirement with respect to being able to certify drawings, for example, and really practice as an engineer. So in Canada, it would be very rare, I would say, for a practicing engineer not to be a P.Eng. And I believe it's similar to the requirements in the States. We have a law and ethics exam, there's experience requirements, education requirements. And in many Canadian provinces, but not all yet, which is a little bit funny, you also have continuing education requirements. So where I had been practicing in Ontario, there is currently no continuing education requirement. But I think it's probably the last province for that to be the case. I think there's a move afoot to change that right now.
So that actually does sound very similar to the U.S. case for the PE certification, where, like you said, there's continuing education, at least in most places, and you definitely had to get some education and take some tests, and you have to work under other professional engineers before you can get your own certification. So,
definitely.
I think the point is, you know what you're talking about.
Well, thank you very much.
All right. So this podcast is all about important engineering terms, or terms that engineers should know and maybe people outside of engineering should know. And the term that I wanted to bring up today is very much related to the term we spoke about last time. Last time we brought up validation as our engineering word of the day. And today I wanted to talk about verification, which I understand is one of your favorite engineering words.
Yeah, absolutely. So validation and verification together is one of my favorite kind of concepts.
Yeah, tell me about that.
So, the last time we spoke, we talked about validation being building the right thing. Verification is about building that thing right. So where validation is designing something or doing something that actually satisfies the customer's need, that all happens on paper, right? You can explain to a client what you want to do for a design, and they can tell you, okay, that sounds great, that'll fit the need. Verification is what happens once you've actually built whatever it is you're doing, be that a process, a product, you name it. Verification is the act of testing or analyzing that product to make sure that whatever it is you designed actually performs as you expect it. So let's say, for example, a client wants a car and you design a car. That's a valid design. But when you go to verify it, if that car doesn't go 200 kilometers an hour, and that was the requirement that the client gave you, then you have not produced a design that actually does the job. It may have been valid, but failed verification. So both of the V words are critical with respect to successful design.
You can't do just one or the other. An engineer has to do both.
Absolutely. Absolutely. Yeah. Because if you don't validate, you don't know that you built the right thing in the first place. And if you don't verify, you don't know that it really does what you said it would on paper.
That's a subtle difference, and I'm sure there are some people who, if they've never thought about those differences here, they're sitting there thinking about that.
Yeah.
How can someone learn more about these differences or think about these differences? Are there any like ways to teach themselves the subtleties of this?
It's probably the best way to think about it is that in validation, it's the client who can validate. Right? It's only the client who can tell you what you've done is right. But when you verify, that's something you check. That's
you as the engineer.
You as the engineer. And there are a couple different ways to verify your design. You can test it. You can do analysis. So, for example, structural engineers do finite element analysis. So instead of physically crushing their design, they can use a computer to figure out whether or not the stress and strain matches up with what they expected. You can verify something through design, which is kind of a silly thing. The idea there is if the client asks for something blue, you design it to be blue and you can see that it's blue, right?
Sure.
But the point there is that you do have to actually check at the end of the day that you've met all those requirements. Even the things that aren't really hard to verify, you still have to verify them. It's amazing how many simple things can get missed, especially in a complex design.
Sure. And so in the last conversation, the last episode, you had said that validation is kind of an ongoing process. You involve the client from the very beginning and you kind of keep on contacting the client and referring to the client to make sure that your design is being validated. Do you think that verification is something that engineers kind of do throughout the design cycle as well?
To some extent, yeah. Looking back through your old podcasts, I noticed one of the words of the day was iterate. Is that right?
Yeah. Yep.
Yeah.
That was my first one.
So there's iteration occurs when you test over and over and over again, right? You can do iterative verification because often a design doesn't work the way you think it will the first time. So you go back to the drawing board, you try the design again.
I'm very familiar.
Yeah, absolutely. Anyone who's practiced for any length of time can know that. But then you can also verify recursively. So recursion happens when you're doing the same process at different levels of the design. So, for example, you can verify a subsystem and say, okay, yep, that subsystem, all the tests passed, all the analysis looks good. Then that subsystem gets plugged into its parent system. So, for example, I mentioned before that I had worked in the rail industry.
Yeah.
Maybe you test a propulsion system, you verify it, and it does what it's meant to do. Well, how does that system now work once it's plugged into a full train? How does it interact with the train controls? How does it coordinate with the braking system? You have to verify the propulsion system at that level as well, once it's plugged into everything and it's part of the bigger picture. So verification, like validation, happens more than once. It's not a point in time. It can happen iteratively and recursively.
And it sounds like there's this hierarchy of it, like simpler tests and then more complicated tests. And we were bringing up even more engineering terms like subsystem, and you probably have to test at different levels of that system and subsystem.
Yeah, and it's a function of how complicated your design is and whether or not it makes sense to look at it as through a systems engineering lens versus a simple or off-the-shelf design.
Right. Okay, well, I think that you've definitely helped clarify some differences between verification and validation, both very important steps when designing something. Any last words for the listeners about anything, about who you are and what you do?
Well, probably most importantly, if you want to learn more about what I do, I've got a ton of free material on my website on engineeringandleadership.com, and I do have a free 12-week engineering and leadership course that you can sign up for. Just take a look on, once you go on the website, just take a look at the right-hand sidebar and you can just plop your email in and sign up for that.
Perfect.
And I'll send you emails for the next couple of weeks.
All right. So, Pat, thank you so much. This is Pat Sweet, professional engineer, and you should check out his website and podcast, engineeringandleadership.com. Thank you.
Thank you very much, Pios. It was a blast.
Thanks for listening. If you're interested in my other strange musings on engineering acronyms, slang, hard to pronounce words, and the like, check out episodes of the podcast Engineering Word of the Day. You can find it at engineeringwordoftheday.com or find it on any podcast player. For all the information on the podcast that you're listening to right now, just go to the show website, k12engineering.net. Please rate and review the show, especially if you're listening on iTunes or on Stitcher. And share the K12 Engineering Education Podcast with your colleagues and your friends. Maybe now that school is starting up, you might find that this show and certain episodes are more relevant, especially the one on teacher dreams and nightmares. Who knows? Message the show on Twitter at K12 Engineering or tweet me directly at Pios Wong. Follow us on Facebook. And finally, you can financially help out this show and me and other projects of Pios Labs by donating on Patreon. The website for them is www.patreon.com/Pios Labs. Our closing music is from Late for School by Bleeptor under a Creative Commons Attribution License. The K12 Engineering Education Podcast is a production of Pios Labs. So the voting window is almost up for the South by Southwest EDU proposals, and I just want to say thank you to everyone who has voted for our session. We saw a lot of likes and a lot of tweets and a lot of Facebook shares for our session, Podcasting for Education meetup. And so Rachel and I, and Southern, because he's helping out a bit too, we're all really grateful for your support. And we hope that we make it. If we do, we'll definitely let you know. You'll hear about it at the end of every episode, I'm sure. And you should totally make it out to Austin, Texas. Join us and engage us in some conversation. Thank you.